All right, I'm going to keep my camera off for this. I'm just going to do a quick rundown of how to derive the 5 equations. Equation 1 and 2. So let's just call this deriving the 5 equations. And that would be for a linear, uniformly accelerated motion. So equation 1 comes from a generic velocity time graph where it starts at v1 and ends up later at some v2 in some time t. And it just comes from the slope. Acceleration comes from the slope. That's from the last chapter on graphing motion, which is rise over run. And the rise, if you've started at v1 and ended at v2, is the difference, v2 minus v1. And then along the bottom, you have time. That's it. That's the derivation for equation 1. Done. Equation number 2. Comes from the area of our same velocity time graph. Starts at some v1, ends at some sort of v2 in some sort of time t. Let's just move over here a little bit. And the displacement is equal to the area. As you can see, this will make a triangle and a rectangular area. So I'm going to remind us of that. So it's a rectangle plus a triangle. And the area of the rectangle down here, length times width, is just going to be v1 times time. That's the length and width of that rectangle. The base and height of the triangle, base times height divided by 2. I'll write that in the triangle, base height over 2. The base, let's just do, we'll do v2 minus v1. That'll be one of the dimensions of the triangle. The other dimension will be time, and of course it is all over 2. Now that is equation 2, but we have to play around with it until it looks like it does on your formula sheet. So first thing I'm going to do is make a common denominator, v1t over 2, multiply the top and bottom of the first term by 2. And then the other term, I'm going to multiply the t in so that I get v2t minus v1t. And that's all over 2 as well. Now we can put those two terms together since they have a common denominator of 2. And I can write this as 2v1t plus v2t minus v1t, all divided by 2. Of course, you should pause this anytime you want when you need to catch up or whatever you got to do. So this term and this term are like terms. There we go. That's what I wanted. v1t, so 2v1t minus v1t will simplify to make just v1t. So we've got v1t plus v2t, all divided by 2. Last step to make it look just like it does on your formula sheet is to factor out the time. So that'll be v1 plus v2 times time. I took it out of there, divided by 2. That is equation number 2. Which way am I going to go? This way? All right. Let's zoom in a little bit. Now, equations 3, 4, and 5 are all done in the same way, but they are different from 1 and 2. So let's go equation number 3. So equation number 3, step 1 is isolate v2 in equation 1. All right, so that's going to be v2 equals v1 plus at. That's just taking equation 1, doing a bit of algebra and isolating v2. And then you just have to sub into equation 2. Equation 2, we just derived, is delta D equals v1 plus v2 in brackets times time, all divided by 2. So what we're going to do is we're going to take this stuff here. I don't like that auto circle. I wish I could turn it off. And substitute it in for V2 down here. If V2 is equal to all that, I should be able to put it in for that. So now I'm going to go delta D equals V1 plus, instead of V2, I'm going to write V1 plus AT. So just to be as clear as I possibly can be, now instead of V2, I have V1 plus AT in equation 2. And that, in essence, is equation number 3. I just now have to play with it until it looks like it does on the formula sheet. First thing I can do is collect those two like terms. V1 plus V1 is 2V1. And then, of course, I still have plus AT, and I still am multiplying by time outside the brackets. And I just have 2 steps left. First step is to multiply time inside the brackets by both terms. So I got delta D equals 2V1t plus AT squared. Multiply t by both of those terms. And then the final step is to divide both terms by 2. So 2V1t divided by 2 is simply V1t. And AT squared divided by 2 is 1/2 AT squared. And that is equation number 3. 2 left. You can go back on this video and have a look at that. So equation number 4, I hope by number 5 it gets kind of predictable. So isolate V1 in equation 1. All right, so that's going to be V1 equals V2 minus AT. Again, just doing some algebra. Sub into equation 2. I'm going to write equation 2 again. V1 plus V2 times time over 2. And I am taking this. Again, I'm going to back up on that. And I'm substituting it in now for V1. So my next line, I'm going to rewrite equation 2 with that in it. Delta D equals, instead of V1, I've got V2 minus AT. I've got plus V2 times time, all divided by 2. Delta D equals, collecting like terms, I've got V2 plus V2 in those brackets, so that's going to be 2V2. By the way, if you feel like pausing this, you can go ahead and see if you can finish this on your own. That's what I had the class do live. It should look almost the same as equation 3 with 2 important but small differences. I'm doing the same sort of things I had to do in the last one. I have to multiply the t in. So what I'm saying is it'd be a nice idea to pause it, see if you could get to the end on your own, but you don't have to do that. 2v2 times t minus at squared, all divided by 2, and then the same last step, delta d is equal to, so 2v2t divided by 2 is just v2t. And then negative AT squared divided by 2 is negative 1/2 AT squared. And that is equation number 4. That is equation 4. The differences, and you don't have to circle these, but let's just go over here so I can see them both in the frame. In equation 3, it's plus instead of minus, and it has a V1 instead of a V2. So you can see right there, compared to here and here. Almost the same steps, just about. Last equation is equation 5. Number 5, it'd be a good spot to pause here and see if it's predictable, the lesson's predictable enough that you can see what the first step is. It's going to say isolate, and then what's the only thing we haven't isolated yet in equation 1? It's time in equation 1. time equals V2 minus V1 all over time. I don't need to rewrite that. And then, of course, we're going to sub into equation 2. I'm going to write equation 2 again. Delta D equals V1 plus V2 times time over 2. Switch to blue. I'm taking this. I'm hitting back. And I'm substituting it in for time. And I'm hitting back again. So let's move down a bit. That's going to be delta D equals V1 plus V2 bracket all over 2. Now instead of time, I'm going to have V2 minus V1 all divided by A. So the denominator is quite easy to figure out. 2 times A, of course, is just 2A. The top's a little more complicated. You could work to FOIL this out, but it's the same two variables where one's minus and one's plus. So there's a difference of squares things happening here, and it will work out if you follow the procedure to V2 squared minus V1 squared. If you FOIL that out, you'll end up with a bunch of terms. The middle terms will cancel out, and you'll just be left with the end terms. And that looks close, but not quite like equation 5 does on your sheet. So we're going to multiply 2a up on this side first. And it's going to be 2a delta d equals v2 squared minus v1 squared. On your formula sheet, it has v2 squared isolated and by itself. So I'm going to take this and I'm going to move it over with this stuff. Minus v1 squared is going to be positive v1 squared on this side, plus 2a delta d equals v2 squared. And that is equation 5. It's written in reverse, though. Of course, on your formula sheet, it just has the v2 squared on the left and the other stuff on the right. But of course, if x equals y, then y equals x. So we'll just write it like that to finish this off. And this is the way that equation 5 is written on your formula sheet, EQ number 5. That's how you derive these formulas. I won't say anything else about that because it takes forever to upload these videos from my house with the bad Wi-Fi that I have. But you can go back and watch these as many times as you want. And there they all are in one frame. If you're looking at this on a phone, that's going to look pretty small, though. All right, so what now? I got to go here. I got to stop the recording. Enjoy.